Hello, welcome to my presentation, Standardized Lab Data Integration based on OPC UA and Allotrope. My name is Heiko Fessenmayr. I'm software architect at Agilent Technologies for lab data and communication standards. So what are the needs of today's labs? So it's foremost in the area of data analytics, monitoring, and also there are enterprise needs. Various software produce proprietary data formats, and Allotrope data formats do a great job providing them as a vendor-neutral format to put them into a data lake and to serve the needs which are shown here on the right side. From Agilent, we are offering Allotrope conversion from OpenLab CDS to the Allotrope formats, and since recently, we are also offering a conversion from Waters Empower to ASM through the Agilent ECM scheduler add-in. But data is one part, communication is the other side. So you want to build connected lab workflows. And for this, you need to have an interoperable communication between the devices, which are orchestrated by some workflow orchestrator. And for these needs, the OPC UA REST communication standard is ideal. Data formats make absolutely sense. Also in the area of online process monitoring, especially BioPharma manufacturing, you have the needs to submit samples, to do analysis, and then provide results back in a vendor-neutral format to the BioPharma process control ecosystem tool. And on the left side, OPC UA is already established today. So that means data format standardization and communication standardization together are needed to do an end-to-end communication. For data formats, Allotrope is doing a great job. For communication, OPC UA REST is doing a great job. But so far, both worked isolated in each area. And so the idea of this presentation is to combine them together to one. Talk about a little bit about the Allotrope ASM JSON format. So for process monitoring and lab workflows in general, they have a direct need for exchange. And so the Allotrope file format is not ideal for this purpose, since you get all the information through one data container, the Allotrope ASM JSON file, and most of the time that results in data overfetching. Also, the JSON container is not ideal for binary raw data since it increases the size. And when you are exchanging files, you have to secure the file folder. So for this, putting together the Allotrope approach with OPC UA is an ideal combination, since in the area of OPC UA, you can just pick what you need through the secure channel, and then you don't have to take care about serialization, since OPC UA does that for you, and the serialization is in a binary format, so this is very efficient, and for sure this is a secure communication. So therefore, Allotrope Foundation and OPC Foundation together with Spectaris announced their collaboration in this area to integrate OPC UA and Allotrope. So how would that look like in combination LATS and Allotrope? So you would have an LATS OPC UA server that integrates the Allotrope data model in a slightly different way as it is exposed today. You would expose the Allotrope raw data as part of the OPC UA Information Model, and therefore it could be consumed securely from the consumers on the right side. How would that look like in detail? So the LATS OPC UA Information Model has a certain pattern, and the result data acquired during a run would be available in the area of functional unit set. So there would an area like program manager result set where you would expose your acquired data. And it's an Allotrope inspired data structure which would expose then, for instance, the raw data acquired during the run. So what are the next steps in this area? So we have Allotrope data model available. So the next step is to turn this into an OPC UA specification that makes it possible to expose the Allotrope inspired data model as part of the OPC UA Information Model. And with the OPC UA model compiler and the LETS model, you can expose this as part of an LETS OPC UA server. And the next steps are done pretty soon here in beginning of November, where we meet in a workshop to talk about more details how to solve drop stop. But we could go one step further. That means chromatography data system could expose their results also in an OPC UA information model with the same benefits as described before. So you could have an analytical data system with an OPC UA data hub that can load data from the data system and expose it in an allotrope inspired way to the outside world. So you can see on the left side how that would look like. And then the consumers on the right side could read the data and could pick it as they needed. Now I will show you first prototypes in these areas. So here the first prototype of an LETS device exposing the LETS OPC model with the Allotrope data model. So you can see here an OPC server running, and here on the back I'm connected through a generic OPC UA client to this OPC server. So you can see here on the left the structure that is exposed by a LETS device. So you can see here the components. I have simulated here an Agilent LC with 4 devices, and then you can see the hardware details and much more. But our interest is in the area of the functional unit set, as you have seen before in the presentation. So we have here the system access, and the system access has a folder called Program Manager, and this contains the result set. And then you have here the LC demo data of a certain run. So you would have here the chromatogram measurement runs, and under this you would see then the details that expose the information like chromatograms, injection, and if you go to the injection you can see then the sample location, for instance. So I can pick this data as I need it, and there is no data overfetching. So this is the first prototype regarding LETS and OPC UA and Allotrope, and I want to switch over to the other prototype, which is a chromatography data system exposing OPC UA and Allotrope information. And so what you see here is the second part of the proof of concept. In this case, this is a chromatography data system, data hub exposing loaded data as OPC UA information model. This is a similar structure as you can see it from the Allotrope data model. Here I have a single injection run, and a chromatogram was recorded. And now I'm picking this information from this client, from the server. So when I do a drag and drop, it picks the measurement data from the server and puts it into the client. And so you can see that is happening instantaneously, and this was picking this number of data. And also, if you want to have the time values, you can pick them. So this is all happening through the secure channel of OPC UA. And if you want to have details from the peaks, you can pick certain values. So for instance, if you want to have the retention time, then you can pick the numerical value of the retention time, so there is no data overfetching.